Now the topic 3, energies of orbitals. Last class we have discussed about the shapes of orbitals. S orbital spherical shape, p orbital dumbbell shape, d orbital double dumbbell shape or clover leaf shape, and f orbital is a complex shape. So already we have learned the principal quantum numbers. N is equal to 1. How many suborbitals are present? Subshells are present. Only one subshell. The value is 0. N is equal to 2. That means L shell. We have two subshells S and P. S is 0 value. P is 1 value. So the S is equal to 0 and P is equal to the magnetic quantum number should be minus 1, 0, plus 1. N is equal to 3. Three subshells S, P, D, and here L is equal to 0, S value is 0 and L is equal to P, 1 value, and L is equal to 2, it is a D orbitals. So S is equal to 0 and P is equal to minus 1, 0, plus 1, and D is equal to, L is equal to 2 value, so minus 2, minus 1, 0, 1, 2. So S is equal to only 1 orbital, P have 3 subshells, 3 suborbitals, and D having 5 orbitals. So in your book, that structure is given like that. Shapes of S and P orbitals. You can draw this structure for S orbitals, and P orbitals we have given some diagram. This is for D orbitals. D orbital value is equal to, actually N is equal to 3. So L is equal to 2. Isn't it? So 5 degenerated orbitals there. So 5 degenerated orbitals dxy, dyz, dxz, dx squared. These three are degenerated orbitals actually equal in energies also. So here the double dumbbell shape or clover leaf shape, the lobes are lying in between the x and y plane here, and these are equal in energies. And this is what dx squared y squared, it is actually the lobes are lying along the axis. Here the lobes are lying along the axis. So here t z squared, this is a dumbbell shape with a donut shape, and this is in these structure, this is two nodal planes are occur. Two nodal planes means that nodal is what? There is no probability of finding electron, isn't it? Electron is 0 in the midpoint. So two nodal plane. So in this lobe midpoint, in this lobe one midpoint. So two nodal planes are occur. But in this side, it is along the axis it is present. So there is no node is present. For f orbitals, lambda is equal to 3 or L is equal to 3. If it is L is equal to 3 means how many m value, how many magnetic quantum number? Totally 7 f orbitals. So 7 f orbitals means minus 3, minus 2, 1, 0, plus 1, plus 2 as well as plus 3. And this is having 3 nodal plane. So 3 nodal plane, it is a very, very complex structure also. So see here 1 nodal plane, 2 nodal plane as well as 3 nodal plane may be occur. This structure is given in the book. Now we are going to see the angular distribution function. What is angular distribution function? The variation of probability of locating the electron on a sphere with the nucleus, and its center depends upon the azimuthal quantum number. Azimuthal quantum number means L of the orbital is which the electron is present. That is angular distribution function. For 1s orbital, it means first cell L is equal to 0, M is equal to 0, and F value theta is equal to 1 by root 2 and G psi 1 by root 2 pi. So therefore the angular distribution function equal to 1 by 2 root. It is depends on the angle theta as well as psi. Here the probability of finding the electron is independent of the direction from the nucleus. So the probability of electron is present in this space, it is independent of the direction from the nucleus. This is angular distribution function. Up to this, we are seeing the shapes of orbitals, S, P, D, F. And what will be the energies of orbital? How much energy for the S, P, D, F orbitals? So, we have taken here the hydrogen atom. Simple. First one, atomic number 1. Only one electron is present for hydrogen. For such one electron system, the energy of electron in the nth orbit is given by the formula En is equal to minus 1312.8 Z squared divided by n squared. And kilojoule per mole, unit is kilojoule per mole. how the energies are occur for the shells. Energies of occur means if you are taking 1s orbital, first cell, only one subcell is present, it must least energy or lowest energy. Second means how many subcells are there? 2s equal to 2p. Third cell, how many subcells? 3s, 3p, 3d. Fourth cell, 4s, 4p, 4d, 4f. Likewise, 5s also. On fourth cell onwards, 4 subcells are present. 5 is also 4 subcells. 6 onwards, 4 subcells and 7 also. 7s up to 7s. So highest value, highest energy level goes to the 7s and least goes to 1s. The electron in the hydrogen atom occupies 1s orbital that has the lowest energy and gains some energy. Suppose at lowest energy level it is sitting, the electrons are sitting in their position, it is said to be a ground state. If you are standing in the floor, ground floor means it is a ground state. Suppose if you are moving to the higher state, if you are stepping to one or two steps forward to the upstairs means it is what excited state. Likewise, the electrons are in this in the air position, it is a ground state. If it is moving to or jumping to 2s or 2p orbital means it is said to be an excited state. Now, how the electron is arranging 1s orbital, 2s orbital as well as 2p, 3s, 3p. So 1s, see here 1s, then it is goes for 2s. Again, it is goes to 3s, 3p. Again, is here 3s, 2s as well as. This is known as alpha principle. According to, see here students, the electrons are arranging in this oneness. In this oneness, the electrons are arranging like that. Then it is moving and to 2s orbitals, right? Again, it is moving to 2p. And then come to 3s. And again, it is moving to 3p. Again, 4s. Then it moves to 3d. Then 4p, 4s. Again, it is moving to 4d. Again, 5p, 6x. And 4s. 5d, 6p. Once again it's moving to 5f. 6d. Then again go for. So this is known as n plus L rule. This is n plus L rule. How the electrons are arranging according to alpha principle. So 1s, 2s. It is known as alpha principle. In this we are going to see this. The electrons n plus L rule. The previous we have seen this is n plus L rule. 1s, 2s, 2p. The structure we are going to write like that. N plus L rule. The ordering of energies of the orbitals in a multi-electron atom. Multi-electron atom means more than one or two atomic number. So increases with the value of n plus L. When the n is number of quantum numbers, L is subshells. Second one, when two orbitals are different. Two orbitals are different in n have the same value of n plus L. So the orbital with a lower value of lower energy state. See here 1s, 2s, 2p, 3s, 3p, 4s up to 5s. In this we are going to see lower 2p value. Let us explain now. In this we are writing how much we are writing a configuration, electronic configuration 1s, 2. Why I am writing 2? Because of first cell, S cell may have only 2 electrons, that is why 1s. Similarly, 2s2, again 2p6, 2p6, again 3s2, 3p6. The electrons are arranged in the increasing order of their energy levels, right? The electrons are arranged in the increasing order of energy level 3s2, 3p6, again 4s2 and 4p6, again 5s2. This is the arrangement and so on, right? Suppose in this we are going to see 2p as well as 3s. 2p as well as how much we calculating the energies are the n plus L value 3s. You must remember S value is 0, P 1 and D is 2, F 3. You understand this? First remember 2p value. 2 is what, children? First, this is nth, isn't it? This is n value. P is what? This is L value. This is n plus L rule. Understand? So 2 is what? N. So I am writing here 2 plus. What is the value of P? P is 1, no? 1. So how much value? 3. And 3 is if n, L, isn't it? N plus L value. N is 3 plus what will be the S value here? 0. So 0. So here 3. So see here both are 3 value. Why we are writing here 2p first than 3s? Why can't we write 3s here? Because the reason n plus L is set. See here in the second one. When the orbitals, two orbitals of different n have the same value. Different n have the same value means what? The different n is what? N is different. Here 2, here 3. But value is what? Similar, no? 3, 3. So at the same time, n plus Lu, the orbital with the lower value of n. So we have to see the lower value of n. The both the values are similar now. Now we are going to see the lowest value of n. So among this, which one is the lowest value? The 2 is the lowest value. That is why in this portion we are writing 2 is first, then 3s. Understand? So this is the first, second rule said that. One more example we can write 3p as well as 4s. Once again we can write 3p, 3p, 4s, right? How can we calculate here? N plus L rule. 3, what will be the value for p? 1. Totally how much? 4. Right. 4 is 4 plus what is the value of S, children? 0. Total value are 4 only. So in this 4s, here 4s to 3p 4s. 3p 4s. Why we are writing 4s next to 3p first? 3p first, 4s next. Because the fourth values are 4. Even though want to see the, if it is same value will be there. So we are going to see n value. N plus L value same means we have to see the nth value now. Nth value means the 3 is the least value than the 4. That is why while writing the configuration, we are writing 3 is first than the 4s. This is the second rule, n plus L rule. Third one is what, children? 3D as well as 4p. The same value. 3p, again sorry, 3D as well as 4p. 4p. You can tell now. What is the n plus L value? 3. What will be the value of D, children? S is 0, P is 1, T is 2. So 2 means 5. 5 value. Here 4p, 4 plus 1. Okay. Automatically it is also 5. So both the values are 5 here. So why I am writing 3D first than the 4p? Because the reason of D. Want to see the D. So D means what? 3 is the lowest value. That's why while I am writing the configuration, 3D comes first than the 4p. So this is known as n plus L rule. According to Offa principle, we are writing 1s, 2s. Like that you have to go write the configuration also. So in this video, we are discussing about n plus L rule. Understand, children? So we will see in the next class.